developed a whole lot of different circuits. He was responsible for AC power, three-phase power that we use today. He also did some things that even today we don't quite understand. One thing that he did was he was trying to send power, electricity, without wires. And he did some experiments on this. We still don't understand today what he was doing, exactly how he made it work. I was doing some research on Nikola Tesla and reading some of his writings. And one thing that he was working on was if you're going to send power without wires, to broadcast power to your house, your house, your house, your house, you have to make sure you know that I'm getting the power to your house and controlling that, and controlling the power to your house and your house. So that electricity, he thought, was a lot like light. And light can be broken up into different colors. So you can get red light and green light and blue light and so forth. So he thought there must be a similar property of electricity. So he called that chromatic electricity. And I did some reading and I built a little thing based on his writings of what chromatic electricity was. But you understand circuits. And you know, for example, that a switch is going to be connected to a light. So if I want to turn on this light, I'll turn on that switch, right? And the same thing for this one, and the yellow one, and the red one, okay? And that all makes pretty good sense, right? Okay? But according to Nikola Tesla, who was a very smart man, he had this idea that chromatic electricity, the color of the switch, should find the right light bulb. So if I wanted to turn on this light bulb, what switch should I turn on?
The green.
Of course. And the blue one, which switch should I turn on for that one?
The blue one.
Of course. And the yellow one would be the yellow one, and the red one would be the red one. Make sense so far? Okay. Now, we can swap these guys. Okay? Now, if I swap those guys, and I wanted to say like this bulb, what switch should I turn on?
Yellow.
Of course. And this one?
Red.
Yeah. How about this one? Of course, and then of course the green one. Now, about this time, you're probably thinking there must be some pattern going on here. So, why don't you take all the bulbs out? All right, I'll help. And why don't you guys pick where you want the bulbs to go? What bulb do you want here?
Red.
Red one there? Okay.
Yellow one next.
Yellow one next.
And the green.
And the green.
And the blue.
No, I
Then
think the green should be last.
Oh, the green last?
Yeah. No, green last.
All right, green last. All right. Now, you mixed them all up, right? This bulb should be which switch?
Yellow.
Of course. This bulb?
Red.
Yeah, right. How about here?
Green.
Yeah, and blue. You know, the interesting thing that I found dealing with Nikola Tesla was that I could take all the bulbs out, and these switch covers, notice, are removable. You guys figure out where you want everything to go.
Blue.
Blue. Okay. Don't stick your finger in the socket. Okay. Blue. Okay.
Green last.
Green last, still, okay. And where? Somebody else want to make a suggestion?
Yellow first. Red in the middle.
Red in the middle.
Yellow first.
All right. Now you got to figure out where you want the switches to go.
Red, blue, green, yellow.
What did last? Yellow should go in front of blue.
Yellow should go in front of blue.
Green should go in front of yellow.
Green should go in front of yellow. Then you're going to put the red in front of the red. That way you want it?
Yeah.
Okay. Well, it makes sense since you put the red switch in front of the red that it should light the red bulb.
Yeah.
I mean, that makes perfect sense. All right. Should the blue switch light the green bulb?
No.
No. That should light the green bulb. All right. And then, of course, the yellow lights the yellow, and then the blue lights the blue. Now, all of this works according to Nikola Tesla. But, you know, I'm an engineer, and I know how circuits work. And you guys know how circuits work, right? Isn't it true, isn't it true that when you wire something up and you wire the switch to the bulb, that the switch that's wired to the bulb should turn on the bulb? The same thing, same thing, same thing. Because this is what makes sense to me. So when you guys go home, look up on the internet, because it's the only place that you're going to find something like this. Because the internet, everything on the internet is true, you know, right? Everything on the, look up on the internet, chromatic electricity. And when you come back next semester, you tell me how it works.
Who said they're wires?
I don't know what I said.
Okay? Next time, you guys all tell me how it works. Does it make sense to you?